these drugs, they reduce the craving for palatable foods. You know, we have this food noise environment at the moment where you can eat all these savory, nice, sweet things. And when you take this drug, you lose interest in them. So why is that?
Yes, thank you for that question. It's a topic that's very dear to my heart, right? I actually had the first publication on this in 2007 when we showed that animals who were being treated at the time, they actually selectively reduced kind of interesting food like candy and chocolate, and then they increased normal like rat chow, right? So we saw, wow, that was interesting. And then later on, we've taken it into clinical trials where we see exactly as you say, you know, one thing is that there's a reduction in energy intake. So we call that the homeostatic response, right? Where people feel more satiated, they feel less hungry. But then we also have these effects on what people eat, on how they respond to cravings, and the food noise is the newest thing, right? This all relates to the hedonic system or the reward system, whatever we call it, where GLP-1 has effect on that. And of course, eating too much is not good, or too much of too good stuff, right? Then that can be like a form of addiction. So that's what GLP-1 does. It has effect on the reward centers. It works on various different places in the brain. Sometimes it comes from the hypothalamus, it comes from the hindbrain, it comes from the septal, but then it also impacts on the amygdala, for example, which is a very a well-known side of the brain that has to do with what is your instant response to things.
So would you say that GLP-1 agonists reduce your addiction, or you get rid of your addiction to like these palatable foods when you take GLP-1 agonists?
Yeah, so I think it's too strong to say you get rid of, right? But you can help to reduce the cravings and reduce the addictions towards these different palatable foods. It's not a cure, right? And it's probably also quite variable for the individual person to one person to another, how people respond. And some people like savory food, some people like sugary food, some people just like all kinds of food, just as like me, right? So I think it's probably variable, but I think for many, yes, it will help curb the addiction.
Yeah. Actually, did you try it yourself once? Because when you develop such a drug, such a powerful drug that kind of changes the reward system, that makes you eat less, did you try it yourself as a researcher?
No, I didn't try it. You know, I'm not allowed to do that.
But it would be interesting.
It would be interesting. You should try your own medicine, right? But I didn't. I'm not allowed.
Okay.
And I'm
obviously
I'm not in.
That's right. That's right. But just out of interest, I think.
Yeah.
This would be probably an interesting thing. Another question. Now we have like 3 different weight loss drugs, like GLP-1 agonists. We have semaglutide, we have liraglutide, and we have tirzepatid. So are there differences between them? And if yes, what are these differences?
Yes. So there's absolutely differences, right? So I was most involved with the first generation GLP-1, which was liraglutide, where I'm a co-inventor of that molecule, which was the first GLP-1 to get approved for obesity. And the weight loss is okay, but it's not as good as the other one. So we keep evolving, and then liraglutide and semaglutide are pure GLP-1 receptor agonists, right? So they only work on the GLP-1 receptor. Tirzepatide then actually works on 2 different receptors. So of course that's like 2 medicines in one. And that has shown, of course, also really good weight loss. What's interesting is that it doesn't seem to be providing like superior benefits on the cardiovascular system. So we still need to kind of understand that. But for the weight loss, there are clear differences. And where we have been able to provide more and more weight loss, and probably we can still improve on them. You know, I like to have these historic references as well. You know, if we look at insulin, right, we've had insulin for 100 years and we've seen multiple product innovations. We've had GLP-1s on the market for 20 years. So we're likely to see more differentiation, more innovation in the area.
Okay. Me personally, I'm doing research in so-called metabolic phenotypes. We identified in our research so-called thrifty and spendthrift phenotypes. So people where we can predict actually that when they do a diet, they lose very good their weight, or they have some resistance in weight loss. And we can predict this by measuring these metabolic phenotypes by measuring the energy expenditure after a meal, a specific meal.
Yeah.
And we also know that there are responders and non-responders for these weight loss drugs. So do you think that we can be able in the future to predict who is responding and who is non-responding to these drugs? And might these phenotypes play a role in the future?
You know, GLP-1 has taught me to never say never, right? Because there's always, we always learn more stuff, right? We used to think that there wasn't really genotypes with GLP, but that's not true, right? There are mutations in the GLP-1 receptor, and there are people who respond a little bit less. It's not a strong genotype, right? But there's definitely something. When it comes to who responds, right? I like to say, you know, it's super easy because GLP-1 acts so quickly, right? So you know the next day whether there's a response to with glucose. You know also whether people feel this effect on to eat less and feel differently about it. You know that instantly. And so it actually is very easy to find out whether people respond. It's a little bit more difficult if we're talking about some of the obesity-related comorbidities, whether that takes a little bit longer time to see that. But for the primary benefits as we see them now, glucose and weight loss, it's super easy to see if people respond. Right?
So just after one day when people really feel that their appetite is basically gone, then you would consider them to be a responder of this drug. So
yeah, I would, right? But of course, it can also become more sophisticated, and I think we will see the world go that way. That some people will be interested in actually using their own data to become more informed. And also that it could be both to have your own proteomics. You have your personalized proteomics app and you can follow what's happening. You have more digital tools to kind of help you be aware with what you're actually eating. You can actually do that today. I'm sure you might have tried it, right? It's like pictures of your phone. You have a small app that ChatGPT made for you, and then you will actually get concrete guidance on how did you eat and how much and how could you actually maybe change that to improve your metabolism potentially. And there are also, of course, the meta glasses that you can use to record what you eat. So I think technology could actually really also help there. But I'm sure you're right that there will be personalized medicine also coming for these diseases. It's just that this drug class right now actually has a response on the majority of people.
We know that these GLP-1 agonists, they reduce appetite, but a lot of my followers also ask if they actually increase metabolism, so that you lose weight by having a faster metabolism.
Yeah. So scientifically, I would have to say that it's for the majority, it will be that they reduce energy intake. And like for semaglutid, it's like 35% reduction in energy intake. There is no data that shows that it improves metabolism. There are some studies in animals that show that with the weight loss, you have a maintained energy expenditure, which, you know, of course, normally you lose your weight, you reduce your energy expenditure or your metabolism. But we don't have any clinical studies that support that. But of course, again, there could be variability. And if people feel that they get help that way, of course, it's great. It's super difficult, as you know, to show it. Because how do you do a study like that where there isn't, you need a control that has the same weight loss, but that's really difficult without a medicine, right?
That's right. I'm a brown adipose tissue researcher also. Do you think that these drugs have an effect on brown adipose tissue activity?
So in mouse, yes, for sure, that's a real possibility. In humans, maybe you can educate me about the relevance of brown adipose tissue in humans. So it's a possibility. I just haven't seen any evidence for it.
Okay. When people take these drugs, they also lose muscle mass. And a lot of my followers, they ask me, how can you prevent muscle mass loss with these drugs? Is it actually more than on a normal diet compared to a normal diet? Or is it comparable, and how can you prevent it?
So scientifically, there are no GLP-1 receptors on muscle tissue of any kind, right? So it's not a specific effect. But when you lose weight, and the faster you lose weight, the more you will also lose muscle mass. And I think the way to prevent it is to have as much exercise as possible while you lose weight and lose weight as slowly as possible.
Would you think that it makes sense combining, for example, semaglutide or other GLP-1 agonists with a drug that inhibits muscle mass loss, like a myostatin inhibitor, for example?
I think it makes a lot of sense. We just need to have the evidence that it's then efficacious and also that it's safe.
Yeah, okay. So what do you think is the next big thing in this metabolic research, weight loss research area? Are there new weight loss drugs coming on the market? What is the next big thing?
So for me, what's next is actually getting some of the more potential benefits on the brain described better, right? So there are other addictions. There's depression, anxiety. There's all the neurodegenerative diseases where we have some very exciting things ongoing. So I think that's what is next for me, to actually get those benefits, potential benefits better described for these medicines. I also think you could actually start thinking about a drug like semaglutide being a longevity medicine. You know, if you look at what is longevity, then it's living longer, living healthier. And then there's, of course, also these effects on epigenetics and telomeres and all of that. But if you just look at the two first ones, do people live longer when they are treated to these medicines? Yes, they do. We have multiple studies that show an effect to reduce death. And then we have all of the benefits on the organs where we see that we have healthier aging. So I think you could actually call semaglutide a longevity medicine. And I think that's something that resonates with the individual or person. So I think that's when you look at the longevity field, that there's so much funding going to that field, and when you look at what they're actually doing, they're looking at medicines for serious chronic diseases, just like the ones that we have done with GLP-1. They just come at it from a different angle. So I think looking at the combined benefits, I think excites me, because why do we have to look at diabetes, obesity, cardiovascular? Why can we not have a conversation about the totality of the things you're getting with these medicines?